All right, guys, how's everybody doing? Today is chapter 6,
Mm.
Geosphere Interactions. When we last left off, we talked about hydrosphere interactions with the other portion we did on Tuesday. This one's on geosphere interactions. That works. Okay, now, big question for today is how does the geosphere interact with Earth's other spheres? So how's the blah, blah, blah. That's tough now that I've noticed. We're going to move past this and pretend it didn't happen. How does the geosphere interact with Earth's other spheres? Great question. That's our big question. So I'm going to go ahead down right here. And let's talk about this first paragraph right here. I'm going to read this going here. Near volcanic islands in the South Pacific, the ocean suddenly begins to boil and froth. Gases explode into the air along with fragments of lava that have been cooled and hardened by the seawater. For several days, the lava erupts at the sea surface, foaming a steaming, lifeless island that looks more like the moon than other islands in the area. A week later, the eruption is over. Birds leave droppings that contain some seeds from different fruits that they ate. The wind and sea carry more seeds to the new island. Rainfall supplies water. Over time, the island develops a layer of soil in which different plants take hold and reproduce. Fascinating. Yes, I did read that very well. Okay, this is one example of how the geosphere can interact with Earth's other surfaces, other spheres, sorry. Again, the spheres is killing me. And produce a new home for organisms. Like other interactions between spheres, some parts happen quickly, others happen slowly. The new island formed in matter of days, but other effects between the geosphere and the island's biosphere may take quite a while, take years to develop. So right here we have above satellite picture of a volcano, part of the geosphere that produces new land. Interactions with Earth's other spheres transform the bare rock into a place that supports life. Okay. So coming back to our big question, how does the geosphere interact with Earth's other spheres? Well, did quite a bit right there on making that whole new piece of land here. So, but let's take a look now at the geosphere interacting with the atmosphere. Think of moving air mass or wind blowing across the ocean toward land. Yeah, good sound effect. The air mass is picking up water vapor from the ocean. What will happen to this moist air mass if it reaches new land? Will it continue to move in the same direction? Will it release its water vapor as precipitation, which we know precipitation is rainfall, snow, sleet, hail, anything that involves the water coming down from the clouds? It depends largely on the land itself. If the land is relatively warm, then the air mass could be warmed by heat rising off the land. The land is cold or the air mass collides with a colder air mass, then the water vapor condense into a fog or become a large cloud. If condenses enough, the cloud could release the water as precipitation. The temperature of the land is one factor of the effects of interaction between the geosphere and the hydrosphere. Another is the shape of the land. If a moving air mass that contains water vapor runs into a mountain, the air mass will be forced to rise to a higher level. The higher elevation will be cooler. This will cause the vapor to condense in a cloud. Down here, we have a little illustration of the sea. We have our water right here. I'm going to do a little drawing for us. This is our body of water. Evaporation comes in, warm, moist air, darker cloud represents that it's really thick with water and moisture and everything. Then eventually gets too dark, releases precipitation. As a result of this condensation, the wind facing, or we call it the windward side of the mountain, is much more likely to receive precipitation than the opposite, which is called the leeward side of the mountain. Most of the rain in the air mass falls on the windward side of the mountain. In fact, the leeward side of the mountain is often as what's it could be known as what's called a rain shadow. A shadow is an area that gets very little precipitation because the atmosphere does not receive much moisture from the other side. It kind of takes it away. It hogs up all the good rain, snow. It's kind of selfish like that. Landscapes and rain shadows are often grasslands or other desert biomes. So, in case you didn't know, Pueblo is one of the kind of very small list of places in the US that actually are part of a rain shadow. So, kind of weird. You should, if you get a chance, Google it up. There's a couple other places in Colorado, but Pueblo is one of those that's kind of in this rain shadow of things. The places around us get a lot more rain or snow, but we don't get quite as much, and that's true with us being a grassland or deserty area. So a large landform that forces moist air, so we had on the other picture, can produce an effect called a rain shadow. One side of the landform is green and foresty thanks to frequent precipitation. The other side is not so much. We're grassland, desert. So rain shadow is definitely what Pueblo is. And we got our little vocab right there. Okay. So, fun fact on that one, where Pueblo is actually part of that list. It's a very weird phenomenon. Okay. Okay, scrolling down here. Sorry, mouse went a little crazy on here. The geosphere interacts with the hydrosphere. The shape of land affects where and how water is collected. A tall mountain range is likely to have a cold climate near its peaks. Any precipitation that falls there is likely to be snow or ice. We know this is true because we see mountains quite a bit. That means it could build up and remain frozen for a very long time. If the mountain range is shaped to trap that frozen precipitation, it could remain in place even longer. The overall impact of this can affect the entire hydrosphere at a global scale. If more water accumulates on the land mass as snow or ice, that means less water is available for the ocean. Lakes, rivers, and underground, this is what occurs during an ice age. Land masses accumulate so much snow and ice that the sea levels drop. The large volume of ice that builds up will eventually be called glaciers. That's pretty big. That whole piece of rock right there, you can see the rock part. And then you can see this right here. You can see the different colors. That will be our glacier right there, which is a very slow moving piece of ice that's slowly carving the mountain. It's still big and frozen, but it does melt a very small portion. At the same time, it is scraping against that mountain, carving stuff out. So very cool. Moving sediments. Love it, love it. When precipitation melts or in liquid form, the shape of land affects where it flows. Lands and ponds where the water cannot drain away any surface, rivers or streams occurs, the geosphere shapes allow for water to gather and flow toward the sea. So on this next part, we have the Pangea portion. Okay. So I believe right down here. Earth used to have a single fused landmass that scientists called Pangea. Over time, the continents have broken up, forming new oceans, seas, and lakes, moving those land masses around. I'm going to start right here. The arrangement of the land masses is constantly changing. I just gave the example of Pangea right here because it kind of looks like a big giant puzzle. The Pacific Ocean is widening by about 10 centimeters per year because Earth's crust is broken up into these plates. As the plates slowly drift over the course of 1,000,000 years, the movement of continents determines the changing shapes of oceans. So 10 centimeters a year, which is not that much. Really not a whole lot, but it's pretty interesting after it accumulates for so long. All right. The next one is rocks and aquifers. That's how you say it, aquifers. A geosphere also affects the underground portion of the hydrosphere. For example, on this one, a sandy landscape will allow rainwater to seep underground, which means kind of soaked in, going, whatever, where underground layers are cracked or porous, lots of pores, like in your skin, little tiny little holes, gross, but in ground, not as gross, where a large volume of water collects. An aquifer may form there. An aquifer is an underground region of rocky material containing water that could be drawn through a well. Aquifers are important. Are important. They can be groundwater resources for humans, especially in areas that do not have large bodies of usable water at the surface. An aquifer can change over time, though, is pulled out of lots and seeps in out of it of water. That whole sentence sounded terrible. Let's try that again. An aquifer can change over time if water is pulled out of it or a lot of water seeps into it. For example, during rainy season, an aquifer surface may rise. This causes the groundwater to get closer to the surface. Sorry. The water table is the upper surface of groundwater. So when you think of the table, the very top of the table. Okay. Don't laugh at my table, but it's at the very top. Okay, that's how I kind of know what that is the upper surface layer of it. Where the earth material is saturated with water. The water table may fall during the summer as groundwater is tapped by wells for drinking water or farming. Okay, right here we have wells are dug into the ground to tap into an aquifer. The well should be deep enough to reach the water table when it falls to its lowest point. Because if you do not make the well deep enough and it's above the water table, you cannot get water at that time. All right. So that one was rocks and aquifers, very important on there. Okay. On this part, we're going to talk about with soil. The geosphere and the biosphere interact with the formation of soil. It's a very dark brown material that makes up the top layer of Earth's lands. It contains a mix of rock, particles of clay, the remains of organisms, fallen leaves, dead grass, animal remains, animal waste, seed husks, and so on. Anything that was alive is kind of now dead. Awkward. But it's important because it helps our plants. Weathering and erosion produce the rock sediments that are inorganic again parts of soil. Organisms add organic material and nutrients to the ground. For example, birds that land on new island will leave their droppings, gross, but kind of not really, but is what it is, which are rich with nutrients and may even contain seeds because their bodies don't digest them or break them down. They kind of just pass right through. Now, when the lands are really rich with nutrients, those seeds will eventually sprout and turn into plants, which we talked about the islands above. When organisms die, their remains decompose. We know that word means to break down when we talked about our decomposers and release nutrients that improve the soil. Over time, the accumulation of organic material makes soil richer and better for the survival of growth of plant life and other organisms. So, very cool right here. These plants are among the first to sprout in this volcanic landscape. Over time, their remains will combine with weathered rock, volcanic rock, particles to form in the soil, in which other organisms will be able to live and hopefully thrive. As you can see, pretty desolate area, except for this small area. So, pretty cool on that one. And eventually, over time, it builds up more and more. Words to know that we talked about inorganic and organic. Inorganic describes materials that are made from non-living things, such as rock. Organic is from living. Okay, last page for us here. The geosphere interacting with the biosphere. Now, on the biosphere, remember, is the Earth's living part of it. Just as the location, shapes, and elevations of the geosphere's land masses affect the hydrosphere, they also affect the living part, the biosphere. A new island is a potential new home for land dwelling organisms. A vast continent with different elevations, climates, soil types, and places where the hydrosphere can provide fresh water has many potential homes for organisms. In some cases, the geosphere is all by itself a home for organisms. For example, a desert fox can dig a burrow in the sandy soil and take shelter where the temperature drops. Bats can take shelter in rocky caves. Plants can take roots in cracks and boulders and cliff sides. Sea turtles dig nests in sandy beaches and lay their eggs in them. In addition to providing a home for many organisms, the geosphere provides chemicals that organisms need. These chemicals, known as minerals, sorry, felt right, contain elements that are essential for plants. Example: phosphorus, iron, magnesium, potassium, sodium, and calcium. These minerals dissolve into water from the surfaces of rock and sediment. The water can then be absorbed by plant roots, which means chemicals from the minerals will be absorbed as well. Okay, very cool stuff. So we learned quite a bit different ways how the geosphere interacts with a bunch of the other spheres on planet. Thank you guys for watching. Sorry I bumbled a lot of words tonight. It may be just because it's almost Thursday. Who knows? All right. Thank you guys. You guys have a fantastic day. Later.